Chapter, I will start first question. Exercise 15.1, first question. A very simple question. So fill in the blanks. That is nothing but complete the following statements by using all the definitions already discussed. First question is probability of an event E plus probability of the event not E means P of E plus P of not E is equal to always 1. Probability of an event plus probability of complement of an event that gives us 1. Second one, probability of an event that cannot happen is 0. That cannot happen is nothing but 0. Such an event is called impossible event. Impossible event. Probability of an event that cannot happen is nothing but 0. Such an event is called impossible event. Third one, probability of event is certain to happen is nothing but certain event or sure event. Sure event. The sum of all the probabilities of all of elementary event of an experiment is equal to always 1. The sum of all the probabilities of elementary event of an experiment is 1. Next, last question. The probability of an event is greater than or equal to 1, greater than or equal to 1, and less than or equal to 0. That is nothing but probability of an event is always greater than or equal to 1. So less than or equal to 1 and greater than or equal to 0. P of E is always greater than or equal to 0 and less than or equal to 1. Less than or equal to 1. It lies between 0 and 1. It lies between 0 and 1. So these are the simple questions. Arrange these in your classwork. Now by using the same second main and third main also I will discuss here. Second question is which of the following experiments have equally likely outcomes and explain. So I will read out these given points. Which of the following are equally likely? Equally likely means, so you have to take one experiment like toss a coin. If you have to increase, for example, if you have to toss coins 10 times, you may get 4 times head, 6 times tail. Same experiment can be done by other student. You may get 3, 7. One more student, you may get 5, 5, like 7, 3. It may change. If you have to increase the number of experiment in the experiment, outcomes you have to increase like 50 times, 100 times, 1000 times. So outcomes may equally likely means equally same. So 50-50, like if you have to take 10, 100 times, so 40, 45 times yet, remaining times will be tail, like see at tail alternate will be there. So that is nothing but equally likely outcomes. If you have to increase the number of outcomes possibility, so will be equally likely, not exact, equally likely outcomes. See, 4 statements given here. A driver attempts to start a car. The car starts or does not start. Is it a equally likely outcome? We can't say this is equally likely outcome because so many factors affects here. That is nothing but a driver attempts to start a car, the car starts or does not start. So only 2 possibilities are there, but so many factors like based on the season, whether it is a winter or summer, based on that sometimes whether petrol or diesel is available in the car or not. So many factors will affect. So it may or may not, but so many factors other than that will affect. So it is not a equally likely outcome. This is not a case of equally likely outcome. Second one, a player attempts to shoot a basketball. C or E shoots or misses the shot. Here also, based on the skill of the player, it will work. That is nothing but a player attempts to shoot a basketball. C or E shoots or misses the shot based on his skill. If he is good, E can, otherwise not. This is also not a case of equally likely. Third one you have to take note. A trial is made to answer a true false question. The answer is right or wrong. Yes, it is a equally likely. Either it is a true or false. Wherever you have to put either true or false, you have to give to anybody. Either it will be true or false. It will not affect. Okay. Second one, fourth one. A baby is born. It is a boy or a girl. So this is also equally likely because either it will be boy or it will be girl. So these are the two cases. Last 3 and 4 are equally likely outcomes. If you have to toss a coin, either head or tail, that is also equally likely outcomes. So I hope first and second are not, because some factors will affect to that condition. So those are not equally likely, but the third and fourth conditions are equally likely outcomes. Now one more question I will discuss here only. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? Why it is considered as a equally likely? So we can't control. If you have to toss a coin, we can't control the outcome. Either it is a tail or a head. So it is equally likely outcomes in this case. So we can't say particular. We can't control the outcome. So either it will be head or tail. So it is equally likely outcome. So this is a fair way usually we consider. Okay. So equally likely outcomes. We can't predict unpredictable. So always either it will be head or tail. We can't control the outcome. So this is a fair way to decide which team you have to bat first or ball first. Next, one more. Fourth question. Which of the following cannot be the probability of an event? Which of the following cannot be the probability of an event? First one is 2 by 3. 2 by 3 minus 1 by 5. Next C is 15% and D is 0.7%. See, all these can be, but it is not negative. So B is not. B is minus 1.5. Always probability of an event lies between 0 and 1 only. It is not negative. But in this case, B is negative. So B is not possible at all. B is not possible at all. So these are, I think, so 1, 2, 3, 4. First question you are right. Second, third, fourth. If you want, you have to write. Otherwise, keep in your mind. So these are very important for the first 1 mark question. So now I will start next question. Now I will discuss fifth question from exercise 15.1. Question is, if P of E is equal to 0.05, what is the probability of not E? Means probability of not E. So probability of E is given, that is 0.05, and what is the probability of E not? That is nothing but complement of E. P of E above are your right, or P of not E your right. We know that P of E relation plus P of not E or E above are that is equal to 1. This is a like formula. Remember, P of E plus P of not E. P of E plus P of complement E gives us 1. So here substitute the values. So P of E is given, that is 0.05 plus P of not E is equal to 1. Keep this one P of not E here only. Transpose 0.05 to our axis. That gives us P of not E, that is equal to 1 minus 0.05. That gives us 1 minus 0.05 is nothing but what? 0.06. 1 0.05 0.05. 10 minus 5 is 5, 1 carry. 10 minus 1 is 9, 1 carry. This is 0.95. 0.95 is P of not E. If you have to add these two, P of E plus P of not E, that gives us 1. 0.95 plus 0.05 gives us 1. That gives us 1. This is a way, very simple. P of E plus P of not E is equal to 1. By using that condition, we have to solve this question. Very simple. Now I discussed sixth question from exercise 15.1. Question is, a bag contains 11 flavored candies only. A bag contains lemon flavored candies only. Malini takes out only one candy without looking into bag. Okay, Malini takes only one candy without looking into bag. What is the probability that she takes out? First one, an orange flavored candy. Okay, so what is the probability? See, probability of an orange flavor candy is equal to, what is the probability of getting or taking orange flavored candy? This is 0 because there is no orange flavored candy in the bag. There is bag contains only lemon flavored candies. So this is not possible. This is impossible event. This is impossible event. Second one, a lemon flavored candy. So the probability of getting a lemon flavored candy is equal to 1 because the bag contains only lemon flavored candies. She has taken one without looking into the bag. So the probability of a lemon flavored candy is equal to 1. This is a certain event. This is sure event. So these are the very simple questions. So orange flavored candy is not there. So this is impossible event. Lemon flavored candy is there. So this is certain event. So very simple question. We have to write this in our class. Now I discuss seventh question from exercise 15.1. It is given that in group of 3 students, the probability of 2 students not having the same birthday is 0.992. See what is given here? In group of 3 students, the probability of 2 students not having the same birthday is 0.992. It is nothing but P of E naught, means complement of E is given, that is 0.992. What is the probability that the 2 students have same birthday? That is nothing but P of E or to find. See the question. P of 2 students, they are not having the same birthday. That is nothing but P of naught E is given, that is 0.992. What you have to find? P of 2 students, they are having the same birthday. That is nothing but P of E. We need to find. That is a question mark. We know that the relation P of E plus P of naught E or complement of E, that is equal to 1. Substitute the values. P of E is not given, so they will write as it is, plus P of E not E is given, that is 0.992, that is equal to 1. Now P of E is equal to 1 minus 0.992. That gives us 1 minus 0.992. That is 0.992. So 10 minus 2 is 8. That gives us 0. This gives us 0. 0.2. Here as well. 0.008. This is the probability of getting 2 students having the same birthday. Probability of getting having the same birthday. 2 students are having the same birthday is 0.008. 0.008. If you have to add these two, see, probability of an event, that is equal to P of E. 2 students are having the same birthday, that is 0.008, plus not having 0.992, that gives us 1. Check whether it is right or wrong. See, 0.008 is P of E, plus P of not E is 0.992. Whether that gives us 1 or not. You see, 8 plus 2 is 10, 1 carry. 9 plus 1 is 10, 1 carry, 10. So 1 carry 1.000, that is nothing but 1. So our solution is correct. This is the way P of E plus P of not E is equal to 1. So 1, 2, out of 2, any one will not be given, means you can find by using the relation P of E plus P of not E, or P of E plus P of E above bar is equal to 1. By using the lesson we can find this.